Welcome back! In video 1, we learned that dielectrics get polarized in an electric field. Today we are going to make this idea mathematical. We will define the electric dipole, the dipole moment and the polarization vector P. These are fundamental quantities that everything else builds on. First we learn about what is electric dipole and dipole moment. First one, electric dipole. An electric dipole is the simplest possible charge arrangement that creates an electric field in a dielectric. It consists of two equal and opposite charges plus q and minus q separated by a small distance d. Next, dipole moment. The dipole moment is a vector that characterizes the strength and direction of the dipole. It is defined as mu equals q times d. Units are coulomb meter. Coulomb meter. The direction of mu is from the negative charge to the positive charge. Next we learn about what is induced dipole. When we place an atom in an electric field, the nucleus and electron cloud separate slightly, creating an induced dipole. The stronger the field, the larger the separation and the larger the dipole moment. The induced dipole is temporary. Remove the field and the charges return to their original positions. Generally, dielectric materials get polarized when external electric field applied. Some materials or molecules are having permanent dipoles without applying any electrical field. Let me learn about what is permanent dipole. Some molecules like H2O and HCl have a permanent dipole moment even without any external field. This is because the charges in these molecules are not symmetrically distributed. We call these molecules as polar molecules. We will talk about them more when we discuss orientation polarization in upcoming classes. Key definitions. Induced dipole, temporary, caused by an applied electric field. Permanent dipole, exist in polar molecules always, even without a field. According to the nature of dipoles present in dielectrics, dielectric materials are divided into two types. These are non-polar dielectrics and polar dielectrics. First, we will learn about non-polar dielectrics. In non-polar dielectrics, the center of gravity of positive charge coincides with the center of gravity of negative charge. Distance between the two charge centers is 0. Dipole moment mu equals 0. Examples for non-polar dielectrics are H2, N2, CO2, CH4. Next, in polar dielectrics, the center of gravity of positive charge does not coincide with the center of gravity of negative charge. The molecule possesses a permanent dipole moment mu not equal to 0. Examples for polar dielectrics are H2O, HCl, N2O, NH3. Next we learn about what is polarization. Definition of polarization. Polarization P is the most important macroscopic quantity in dielectrics. It is defined as the total dipole moment per unit volume of the dielectric material. Polarization P equals total dipole moment over volume equals sum of mu over V. If there are n atoms or molecules per unit volume and each has dipole moment mu, then P equals n mu coulomb per square meter. Students, I'll go an example for polarization for clear understanding. Think of a classroom with 60 students. Normally, each student sits upright. That is, students are not sitting in a particular direction. There is no net tilting. That is, polarization P equals 0. When the teacher says, look right, each student turns their head slightly. Each student now has a small head turning moment. Polarization P is the total head turning divided by room volume. More students or bigger turns give a larger P. Important properties of polarization P. Property 1. P is a vector quantity. Its direction is the same as the dipole moment direction from negative to positive, which in most dielectrics is the same as the applied field direction. Property 2. Without an electric field, P equals 0 for most dielectrics. The dipoles are randomly oriented and cancel out. Property 3. For linear dielectrics, P is directly proportional to the applied field E. Key formula. P equals epsilon naught chi sub E, where chi sub E is the electric susceptibility. Next, polarizability. It is denoted by alpha. When the strength of the electric field is increased, the strength of the induced dipole moment is also increased. The dipole moment is directly proportional to the applied field. Nu is proportional to E, implies mu equals alpha E, where alpha is a constant of proportionality called polarizability. Alpha equals mu over E. Summary of this class. Important definitions. electric dipole. Two equal and opposite charges plus q minus q separated by a distance d. Dipole moment mu. Mu equals q times d. Direction negative to positive charge. Unit coulombs meters. Polarization P. Total dipole moment per unit volume. P equals n mu. Unit coulombs per square meter. Induced dipole, temporary, created by an external electric field. Permanent dipole, exists in polar molecules, for example H2O, HCl without any field. Non-polar dielectrics, charge centers coincide implies mu equals 0, for example H2, N2, CO2. Polar dielectrics, charge centers do not coincide implies mu is not equal to 0, for example H2O, HCl, NH3. Susceptibility P equals epsilon naught chi sub E, linear dielectrics. Details in video 3. Polarizability mu equals alpha E, where alpha equals mu over E. This is the end of this class. Please subscribe, like and share this video. Next class we will discuss in detail about what is polarizability, susceptibility and dielectric constant. Thank you.